Hello students, welcome to the Aerobo Automation YouTube channel. In this video, I am going to discuss regenerative circuit in hydraulic system. The first of all, regenerative concept is nothing but we are going to use the oil which is going to the tank instead of going to the tank. For example, extension stroke. In extension stroke, what happens? Oil goes inside the piston chamber and rod chamber oil goes to tank generally, right? So what we can do is, like, instead of sending rod chamber oil to the tank directly, we can reuse it so that we can save some amount of energy. Means we can increase the speed, okay, by adding some extra amount of oil that is coming from rod chamber instead of sending to tank. For example, see, this is a cylinder. During extension stroke, oil should go inside and oil should go outside. So the oil which is coming out of the cylinder, instead of going back to the tank, we are going to redirect to the piston chamber so that the velocity going to increase, right? So that means we are regenerating concept means we are storing some amount of energy, means we are reusing it, okay, the oil, so that we are actually saving some energy, right? So that is what we are talking about now. So to demonstrate this regenerative circuit, take a cylinder and there is a pump station and there is a direction control valve 4x2. So in this case, since I am explaining the regenerative concept, I will take manual operated 4x2 direction control valve. So this one, and we should take a two-way flow control valve, rotate it by 90 degree. I will have it at the input side. P is connected to P, T is connected to T. Extra T port is there, that you connected to T again. And normal circuit is A to this one. Okay, so I'm going to I'll give you a demonstration of this circuit. This is a normal circuit. Means generally oil goes inside the piston chamber. Oil goes from rod chamber to A to tank. Right? You can observe during extension, oil from A to tank is going. That means rod chamber oil is going direct to the tank. See, the amount of oil going to the tank means it is not doing any work. It is simply going to tank. That is the wastage of energy, right? So we are recovering some amount of energy, so that some advantages is like velocity gain. Okay. So now what is the velocity? So to know what is the velocity, double click on the cylinder and enable the velocity meter per second. Go to simulation. Now you can see this velocity. Velocity is during extension is 0.09. Okay. During retraction 0.14. This velocity difference will be there. Extension is slower, retraction is faster because of area difference. Okay. Fine. This is your understood. Now regenerative circuit is, we are going to redirect the oil which is coming from rod chamber to piston chamber, so that extra flow will be there, extra flow rate will be there, so that piston moves faster than the normal circuit. So for that, you just copy this portion. Okay, entire portion you can just copy, paste it, and I'm not going to use the port A. I will block it, that is shut up connection, and B I will connect it to the piston chamber, and rod chamber oil I will connect it to P. That means here at this point here Q means flow total, QT is equal to QP means pump oil plus Q rod chamber oil, QR. But in case of here it is QT is equal to only QP. So here extra amount of oil is there, so that is going to boost the velocity in extension process, right? So again velocity is there, velocity display is there. So I am going to simulate it now. See, during extension this one 0.09, during extension this circuit is 0.22. 0.2 means it's more. This is 0.09, this is 0.22. So velocity is increased, right? So this is the demonstration, that means rerouting the oil from the rod chamber to the piston chamber, where the advantage is we can increase the speed. Okay, so this is what the regenerative circuit is, and we have a lab video, means lab demonstration also. So you can see after this fluid sim demonstration, there is a lab video is there. That means where we have taken 3 trials for normal circuit. So if you take 3 trials, we have taken 3 trials. So that is time taken to extend is, that is average. We have taken 3 trials, that is average time taken to extend is coming around 2.5 seconds. Okay, actually 2.50 seconds. Okay, and the cylinder stroke length is in the laboratory here in the simulation it is 200 mm, but in the laboratory it is around 400 mm. So stroke length is equal to 400 mm. I want to increase the font size. This is also stroke length is 400 mm, but here time taken is average 2.5 seconds, but here in this circuit average time taken is 1.78 seconds. So how do we calculate velocity? Velocity is nothing but displacement per time, right? So apply this formula, that means you can say V1, okay, V1 is equal to 400, that is in mm, so we have to multiply by or divide by 1000. Okay, that is actually 0.4 meter. 0.4 meter divided by 2.5. Which is calculated, it is coming around 1.6 meter per second. Whereas V2 comes around that is V2 is nothing but 0.4, because 0.4 meter, 400 mm you convert it to meter, divided by 1.78 is equal to 2.2 meter per second. So here you can clearly see that velocity has increased. So this is what recovery of energy, and we are using to increase the velocity. Okay, so this is how the regenerative circuit works. So, and also watch the laboratory video to understand better. So thank you everyone. So in this circuit we are demonstrating regenerative circuit. So before rigging up the regenerative circuit, we are doing the normal circuit, and we are noting down the time taken to reach from one end to other end, that is during extension stroke, time taken to complete the extension stroke. This cylinder stroke is 400 mm stroke, and we have taken 3 readings actually. So 3 times we have taken the reading. So on an average it is coming around 2 seconds, 50 milliseconds. So that is what the during normal circuit without regeneration it is taking the time, that is 2 seconds 50 milliseconds. That is the time taken to complete the extension. Okay, so this is what we have noted down. In the next circuit we are going to implement the regenerative circuit. So by using regenerative circuit, the output should be like, it should take less time than the normal circuit. So that is the concept of regenerative circuit. We are going to demonstrate it now. So now we have added the regenerative circuit here. That means the oil from the rod chamber is going back to again the P port. That means it is rod chamber oil is getting added to the mainstream oil, and it is going to the piston side. So that is why velocity should increase actually. So we have noted down 3 readings, time taken to complete the extension for a distance of 400 mm, and we taken the 3 trials. So we come to know that average time taken is 1.78, okay, 1.78, and we calculated the velocity for without regenerative circuit and with regenerative circuit. Without regenerative circuit is 0.14 meter per second, and with regenerative circuit is 0.22 meter per second, and there is an increase in velocity by 67%. So this is what the demonstration of regenerative circuit.